In this video, we're going to cover the sampling distribution of a proportion. In this section, we'll do statistics on a categorical variable with exactly 2 categories. So, if that happens, we have a few definitions and formulas related to that. And the first one is the sample proportion, which is just the proportion P is x over n, where x is the number of items having the characteristic of interest, and n is the sample size. And this is exactly what you should think of as the formula for proportion in general. So this should make sense, right? We want our number of items with the characteristic we're looking for over the total number of items. And that's exactly what this first thing says. Furthermore, if we know that pi is the population proportion, so the proportion of the entire population, then the standard error of the population is given by this formula. Sigma sub p is equal to the square root of pi times 1 minus pi over n, where again n is the sample size and pi was the population proportion. And finally, we have the z-score. The z-score for a sampling distribution of the proportion is given by this formula here, which is p minus pi all over the square root of pi times 1 minus pi over n. This is actually very similar to how we've calculated the z-score previously, where that formula was the sample mean minus the population mean over the standard deviation, or the standard error. Well, that's exactly what happened here. The proportion minus the population proportion divided by the standard error. All right, and those are the 3 formulas we'll need to use. We have 2 examples with 2 parts each here. First example is in a random sample of 60 people, 45 are classified as successful. So our 2 categories are successful or not. And then the first question here is determine the sample proportion. Well, we just use that first formula. The number of successful people is 45. The sample size was 60, so it's 45 out of 60, or in other words, 0.75. Part B says that if the population proportion is 0.65, determine the standard error. So we just plug it into that second equation. We do that where 0.65 is the population proportion, 60 is the sample size, and this is approximately 0.06158. Right here. And that's actually it for the first example. We have a real-world example that we will try to look at now. And to set that up, the statement is, a survey found that 27% of consumers from country A are more likely to buy stock in a company from that country, so from country A. Suppose you select a sample of 100 respondents from country A. Then the question is, what is the probability that in this sample, fewer than 27% are more likely to buy stock in a company from country A? Well, if our population proportion is 27%, and we're asking for the probability that fewer than 27% are going to buy the stock in the company from country A, well, if we think back to a normal distribution, if we are at our population proportion, or in previous sections, population mean, then half of the things, or half of the options, are below that amount. So if we're asking what the probability that in this sample, fewer than 27% are more likely to buy stock in the company from country A, we should automatically, without doing any math, realize that this probability is 50%. 50% are going to be below the 27% marker, and 50% probability that we're above that marker. Let's actually do the mathematics, though, to see that that's the case. So, to do that, we calculate the z-score of this value. This is our formula for that. Times 1 minus pi all over n. All right, well, this is 0.27 minus 0.27. P is the proportion that we're looking for. Pi is the population proportion. And then we have 0.27 times 1 minus 0.27, all divided by n, which was 100. And we take the square root of all of that. Well, what is this equal to? This is equal to 0 over blah. It doesn't matter what this is. That's non-zero. 0.27 times 0.73 divided by 100, then the square root of that is non-zero. So we get 0 over something that's not 0, so this whole thing is 0, which tells us we have a z-score of 0. What does a z-score equal to 0 imply? Well, that implies that this corresponds to 50% of our options being below this value. So this corresponds to 50%, which is exactly what we said before we did any mathematics. Okay, we have one more question here. We'll finish out this video with that question. What is the probability that between 23% and 31% are more likely to buy stock in the company based in country A? Well, we need to find the z-score for the 31%. So this is 0.31 minus 0.27 all over the square root of 0.27 times 0.73, right? The 1 minus 0.27, all divided by n, which was 100. Excuse me, I'll write 100 there. Well, we do this calculation, we get 0.04 over approximately, I should do an approximation here, 0.04440. And this is approximately 0.9009. Now, what does that z-score tell us? This z-score corresponds to 0.8159 or 81.59%. So the probability that you are lower than 31% more likely to buy stock in a company, that probability is 81.59%. Now, if we find the probability that we're lower than 23%, we can find the probability that we're between those by subtracting off the probability related to 23% from the probability related to 31%. So we do the exact same calculation related to 23. Well, this z-score is 0.23 minus 0.27 all over, and the denominator is actually the same as the previous problem, which we calculated as approximately 0.04440. And what is this? Well, this is negative 0.04 over this. So that's actually negative of our previous value. We look at our table with this z-score, and that corresponds to 0.1841 or 18.41%. So the probability that we are have lower than 23% is 18.41%. So again, to find the probability that we're between these two percentages, we take this and subtract that off. So 81.59% minus 18.41%, and we get 63.18%. And that is the probability that we end up between those two percentages of people that are more likely to buy stock in a company based in country A. And that's it for this video.